Today we are going to show you how to solve a basic statics problem. The first thing that you need to know is what a moment is, which is a force multiplied by the distance from the location that it is acting on. This is often simplified as m equals F times d. For this problem, we are given the moment and the force that is acting on this cantilever beam, and we are going to back calculate the angle that the force is pulling on. The moment is at the far left end of the cantilever, a distance d away from the 4 kilonewton force, which acts at the bottom of the beam, a distance of 0.45 meters down. Using the principles of statics, we can solve for the angle and the force is tilted down. The 4 kilonewton force is a vector that acts in both the x and y directions. So the first step that needs to be done is to resolve the force into its x and y components, and the angle that the vector makes with the horizontal. The first equation that we will use is to sum the moments in the cantilever about point A, where the moment was defined in the problem statement as 10 kilonewton meters. By multiplying the 4 kilonewton force by sine, it breaks it down into the y component, and using cosine we can get the x. These resolved forces are then multiplied by the distance that they act away from point A, 3 meters horizontally or 0.45 meters vertically. Simplifying the equation, we get 12 sine theta minus 1.8 cosine theta equals 10. This relationship can be better seen by drawing the right triangle that is formed by the force. We use the values created by multiplying the force by the moment arm as the legs of the triangle. Using the Pythagorean theorem, we can find that the hypotenuse is equal to the square root of 147.24. The angle theta that we are solving for is the angle that is formed with the horizontal. So first we must solve for phi, which we can then use to find theta. Using the basic relationship between sine and cosine, opposite over hypotenuse, adjacent over hypotenuse, we can create the second equation. Next, we divide equation 1 by the square root of 147.24 to get the following. This creates a new third equation. We can simplify this equation by substituting equation 2 into this new equation to get values in the form of phi and theta. We then realize from geometry that phi is equal to the inverse tangent of 1.8 divided by 12, or 8.53 degrees, and input this as phi. By simplifying the equation and isolating the variable, we get that theta is equal to 64 degrees.